Okay, if we can turn to page 5. We're going to practice a bit more with converting between log and exponential forms, and then we'll talk about log properties today. Okay, so for practice, let's see if we can get through page 5. So I'll do a first few here as a reminder, and then see how far we can get on our own. So starting with number 1, we're trying to evaluate this log expression, and we know that logs in general is just going to feel abstract, but we have a quick way of converting from logs to exponentials. If we can get it as exponential form, it'll just become easier for us to identify because we kind of have a good understanding of exponential properties. So the way we like to start these problems is, I want to convert this to exponential form. Let's get this x to show up because we know that we're trying to figure out what that value is equal to. So let's say it's equal to x. And we're going to go through the process of converting from log form to exponential form. So we like to start with the base, start with that base 5. And we kind of go in a circular motion, and then we pick up values along the way. Okay, so we say 5 raised to the x is equal to 125. So that's the order that we want to. Right? You kind of always think of it as, as long as you know where to start, move in a circular motion, you're able to kind of pick up everything that you need. So this is a lot easier for us to think about, right? So 5 raised to what power is equal to 125? 3. Yeah, that's our answer. Okay, repeat that process for all these problems here. Get that equals to x to show up, convert to exponential form, and once it's in exponential form, we can kind of just logically reason out what the x value must be. Okay, what's x equal to? 8 raised to what power will give me 1? 0. Yep. Okay. 6 raised to the x power is equal to 1 over 36. Let's worry about the 36 to begin with. 6 raised to what power is 36? 2, and then how can I get it in the denominator? Yeah, put a negative in front, right? So 2 will give me the 36. The negative 2 will force it in the denominator. Yep. Okay, so I'll just work through as you guys are doing at the same time. You can check your answer along the way. All right, what's the issue with number 5? Can I raise a positive number to any power and get a negative? No, so there's no solution. Okay. Also, something else to keep in mind is that log can never be, we can never have log of a negative number. Kind of see it why that's the case. No solution. Right. It doesn't matter if I choose any negative number or 0 or positive. I'm never gonna, I can get 49, but I can't get a negative 49 out of this process. Or I can get a 1 over 49, but I can't get a negative to show up. Okay, what's the hidden base here? 10. Okay, 7, I want us to be careful about this. Natural log is same thing as what? ln is same thing as what? Log base e. So log base e, and there's an e squared here, so I don't want us to get confused there. That there's two separate things going on there. This is log base e of e squared equals x. So we can't just say log base e of 2, right? This e is separate from the base. X must be what? 2, right? Get the bases are matching. I can remove them. Just set the exponents equal. There's got to be some root, right? Only way that I can get a large number to turn to a small number, if there's a root involved. Okay, fourth root. We know 4 to the 4th power is 256, so therefore the 4th root of 256 will bring me back down to 4. Okay, what did you guys get for 9? Yeah, 5 squared will give me 25, but I want that 5 to be in the numerator, so I got to flip it. I need a negative in front. All right, can I get the bases to match? Root 10 is same thing as what? 10 to the 1/2. So x is going to be what? Okay. 2 raised to the 5th power is 32, so we know it's going to be a 5th root of 32, but we got to also take this number and move it up. So okay, number 12 feels a little messier. We can do guess and check, which is fine, but maybe the easier path is finding, okay, maybe I can get both of these to share the same base. So what base can I choose? 3, right? So what can I do with this one to convert it? Root 3 is same thing as 3 to the what? And 27 is same thing as 3 to the 3rd. But once my bases are matching, I can just focus my attention to my exponents. Okay, multiply 2 to both sides, x equals 6. Thank you.
Should the homework packet, like, is
Okay.
it like the whole packet do, or?
Which one?
The homework was which one? Yeah. The whole packet.
14, let's get this expanded form to show. Let's get that natural log to be written out so that we can see the full base. Now we want to convert this to exponential form, but something feels a little bit out of place. What feels a little bit out of place here? Yeah, that 3, we want that 3 to be the better spot. If we go through this process, that 3, we don't know where to put that 3. So where else can we put that 3? Yeah, on the other side, right? Let's divide it over. So we'll divide that 3 over. It's a coefficient. We'll divide it over. It'll just feel a little bit cleaner if we have it in that side, and we have all the 3 parts kind of working in sync with each other. Okay, so there feels more, familiar here. We have the base, we got the value, we have where the exponent had the value there, so we'll work our way around. Okay, so now we can clearly see, okay, my bases match. I can just set the exponents equal. Okay, what do you think about 15? No solution, right? I can't raise a positive number to a power and get a negative in return. So no solution. Again, we can't have log or natural log of a negative value, so that's always going to be an issue, but we can also see it from this perspective, from an exponentials perspective. Okay, so we're going to start looking at log properties. It's nice to have a good foundation here, so we can always know how to go back and forth between logs and exponential form. But now we're going to look at some log properties. Actually, before we do that, let's do some of the practice on the top here, just to practice merging some of these terms together. Let's look at this practice from yesterday and Friday. Simplify the exponential expression. If I multiply bases, I can do what with the exponents? Add them, yep. There's a hidden 1 here. Number two, I can think of it as taking out what's shared between numerator and denominator, and essentially I can subtract those numbers and get to wherever there's more m's is going to be where the leftover is going to live, right? So subtract exponents. There's 5 m's up here. There's 2 m's down here. If we take away 2 from both, we're only left with 3. I have 9 down here. I have 2 up here. If I take away 2 from both, I'm only left with 7. Okay. G to the 4th to the 11th. What can I do with these exponents? Multiply. Okay, special properties. Log base b of 1 is equal to, well, we can kind of solve our way through this, okay? And the idea is that log of 1 is always going to be 0. Okay? And the reason why is because this b to the 0 power is equal to 1, right? That makes sense from an exponential perspective. So these are just, I mean, we can always work backwards and convince ourselves, but these occur so often that it's nice to be able to just have these properties kind of memorized. But again, if you don't, you can always confirm it by working your way out and convincing yourself, okay, all right, this must be 0. The second property says this: if my base and my value are the same, I'm always going to get a 1 out of it. Okay? And then why we can convince ourselves, if I convert this to exponential form, that makes sense. Base b raised to the first power is equal to b. We know anything raised to the first power should be itself. Now, the third property is highlighting log and exponential properties. So here, what we're doing is we're inserting the exponential function into the log. So anytime you insert a function into its inverse or the inverse into its function, they're always going to kind of cancel each other out. So anytime I'm inserting the exponential into the log function that shares the same base, I'm just left with what is left in the exponent. And the reason that we know this is true, right, if we go through this process converting to exponential form, b raised to the x is equal to b raised to the x. Same idea. If I take the log function and involve it in the exponent where they share the same base, here I'm basically inserting the log into the exponential function, and the bases also match, and this also leaves me with just that x. I also know this is true. Imagine I want to convert this back into log form. I would say log base b of x is equal to log base b of x. So that makes sense. Same thing. Okay, we have 3 properties that we're going to be using. We're going to stay in logs for these properties. We're not going to convert to exponential form, but it's nice to know these properties. You know how with exponential property, there is that relationship between multiplication and addition? Same thing here. We're going to see that relationship here. And also, remember with exponents, we see this relationship between subtraction and division. Same thing here. Okay, so here are the properties. If I have log base b of u plus log base b of v, I can merge the 2 logs together by multiplying the values. So I can merge the 2 logs together. Sometimes this is very helpful if we want to condense, get it down to one log expression so that we have an easier time moving forward with our problem. Sometimes sometimes the problem requires us to expand it out so that we can take care of individual terms. So the property, sometimes we go from left to right or from right to left. It really depends on the problem. So this process from getting from multiple terms into single terms is called condensing. And then from a single term to multiple terms is called expanding. Here's another property. This is the quotient property. If I subtract two logs, I can merge them together and write the log once and just divide the values over each other. Okay, I'm going to skip this argument here. We're just going to know that these are true and we don't have to go through and confirm it. We'll practice these on the next page. Okay, the third rule is power property. This power property is going to be very useful. This says that if I have log base b of u to the n, usually we can't do this. Usually we can't just move the exponent in front because this is completely different. But within logs, we're able to get that to work, and because of that, it gives us a lot of flexibility in things that we can do. So as long as we have a log expression, the exponent is free to move. Doesn't matter if it's up here or down here, it's the same value. So that's nice because we can move things back and forth depending on what the problem needs. Okay, thank you. Okay, let's go to the next page. And I'm going to have us copy these properties at the top of the page here so that we can practice working them. Okay, so if you guys can put this at the very top, if you can, find room, and you can put off to the side here as well. We don't need all that space for these problems. You can just put it off to the side here. And I'll keep putting this up as well as we refer to them, but just put it at the very top right corner so that on page 7, so it'll be easy to access it. You don't have to keep flipping back and forth. Just copy this down to the top of your page. Okay, so it says use properties of logarithms to expand. So when we expand, we want to get a single term into multiple terms. So we really need to think of the 2 and the x as what we want to expand. So this falls into our product property. We can expand into log base 5 of 2 plus log base 5 of x. So typically, if we're expanding, we're always looking to do product and quotient first. And then once we get that out of the way, then we can worry about the power property. So power property is if we see any leftover exponents, we can drag them down in front. Okay, so for number 2, I want us to see that there are 3 terms at play. You got the 8, you got the a squared, and you got the b to the 5th. And we can separate each of them using plus signs. So I use product property. But there's one more thing that we can do. How can we apply a power property to this halfway point? Yep. Put the 2 in front of its log term and put the 5 in front of its log term. Okay, number 3, which property can we use? Quotient, yeah. These aren't quite formal properties, but I think these are kind of properties that I think is good to know, especially if you have something that's more complex. So let me kind of show you real quick. If I have log of, let's say, AB over CDE, I can expand it. We don't have to go through, oh, wait, I got to do product and quotient and clean all that up separately. The idea is that we can quickly jump to the end by just looking at where they're located. Okay, so wherever your log term is located, that's going to be part of a positive log term. If anything's in the denominator, it's always going to be part of a negative log term. So it's as easy as this. If I have 5 terms I want to resolve and they're spread out between numerator and denominator, I just look at where they're located, and that's going to tell me what sign to use. So if it's part of the numerator, it's going to be part of a positive log. If it's in the denominator, it's going to have to be part of a minus log. And I can also work backwards, right? If I have all these terms, I'm trying to get it into a condensed form, I can just do log big parentheses and look to see where to put the A, B, C, D, and E. If my A and B are positive, it's going to go up top. If my C, D, and E are part of a negative log, they're all just going to get merged together in the denominator. Okay, so taking that into account, let's see if we can look at number 4. I have 16, I have W cubed, and I have X to the 6th. So the 16 and W cubed is going to be part of positive log, and then the denominator here is going to be part of a negative log. Yeah, so wherever they are, that's going to be what sign they're going to get. We do one more thing here, bring those exponents down. Okay, number 5, I really can't expand using product and quotient, but I can use power. What's the hidden base? Well, the base though, 10. Okay, base 10, and then R to the 1/2. Okay, power property, bring that 1/2 down. Okay, I've got log base e as my extended form. How can I rewrite this denominator? Cube root is the same thing as raised to what power? Third. Okay, now this may seem like two separate terms that we can expand, but anytime I have plus sign in between, I can't do anything with it. So I want to point that out as a warning. If I have log of u plus v, we can't do this. Okay, this is stuck. We can't do log of u plus log of v. I know it feels like a very natural thing to do because you're distributing something through, but this log is not an independent thing outside of u plus v. This is inside. We can't distribute something if this is inside the log function. So we can't do this. I mean, our property looks kind of similar, right? Log of uv can be expanded to log of u plus log of v, but log of u plus v is stuck in that form. We can't do anything with it. I know it's natural tendency to want to do this, but this is not a property. But I do want to point that out since it's such a common thing to do. Okay, so the numerator and denominator within their parentheses, it's kind of stuck. We can't do anything with it, but we can separate the top from the bottom here. And there's one more thing that we can do. Yeah, bring the 1/3 down in front of its log term, and that's as far as we can go. But we can't, yeah, this is a common thing. We just feel like, oh, I want to do something with this, but we can't do anything with that. It's kind of stuck in that messy form.
As part of expansion, do you want us to change natural log to log of each base e?
No, you don't have to. I just want to kind of help remind us that natural log is really log base e. So for now, I want you to do that, but if it's on a test or quiz and you did not convert it, that would be fine. Yeah. But for now, I want to keep reminding us, okay, that's just a shorthand form of something of a log of a true base that's being hidden from us. Okay, so that's the expansion part of it. Now we're going to work backwards. Now we're going to condense. So condense, we're trying to get everything down to one log. Now, when you condense, you're going to try to kind of go in the opposite direction here. You're going to take care of all your power property before you do your quotient and product. So we're going to try to start moving all the exponents up to its place, and then we can worry about where they belong. And as you do that, that's where it's going to be helpful to look at what your positive and negative values are. If it's part of a positive term, you can just cleanly just put it up top. If it's part of a negative term, it's going to go below in the denominator. But everything is going to show up as multiplication division. There you shouldn't see any plus signs or minus signs that shows up. Everything is either multiplied or divided. Okay, so let's start looking at 7 here. So we want to condense. So when we condense, let's not look at product and quotient. Let's look at power. So what can we do power-wise? Yep, the 3 can go up as 4 cubed, and the 2 can go up as what? K squared, yep. And this is really base 10. Okay, so now that we have our exponents taken care of, or our coefficient taken care of, now which property are we going to use? Quotient, yeah. Now we're moving from this side to this side. We have the minus. We're going to merge it together as a division. All right, number 8. What can we do first here? Move the, move the 5 and the 3 up as exponents. Now, as I do that, I'm also going to rearrange it. It just feels better to see my property if I have this as my second term, so. Or it's easier to recognize if I have it as my second term. So it's a little bit clearly, right, it's easier to see if my first term is positive. I can see, okay, now I'm doing my quotient property here, same as above. It's harder to see if that negative is first. Okay, so now we need to find a home for g to the 1/3, h to the 1/3, and g to the 6th. They're all going to go under one log. So we have to decide, where does it go? Is it going to go, what's going to go in the numerator and what's going to go in the denominator? What do you guys think? 10 to the 1/3 goes where? Top. H to the 1/3? Yep, because it's positive. And then the g to the 6th denominator, because there's a minus sign. Okay, but the positive and negative is going to tell you where to put it, but you're not going to include a minus and plus in between, right? You're going to multiply or divide everything inside. Okay, the only thing I can do power-wise is bringing that 4 up top, but I can't do anything with that 3n plus 5 and that n minus 1. Those are stuck, okay? I can't do anything with those. Okay, I need to find a home for this term, this term, this term. Can further clean up. Distribute that m to the 4th if you like, but either is fine. Okay, number 11. All right, let me just check your pages here. Just want to check pages 5 through 7.